This video will cover the Geometry Common Core exam from June 2015, questions 17 through 21. Number 17 says Steve drew line segments ABCD, EFG, BF, and CF as shown in the diagram below. Scaling triangle BFC is formed. Which statement will allow Steve to prove ABCD, the line segment, is parallel to segment EFG? And you can see here that we're talking about a bunch of angles being congruent to each other. We need to remember that if lines are parallel, we get a bunch of congruent angles. If lines are parallel, then alternate interior angles are congruent. Alternate interior angles are congruent. And if we think about alternate interior angles, they are formed out of the letter Z. We also find that corresponding angles are congruent. This looks like angles that match up. So say here and here. If lines are parallel, we also know that alternate exterior angles are congruent. So the picture for this is alternating angles that are exterior or outside of your parallel lines. So if we look at this picture, we want to try and focus on a Z. Looking for a Z is your best option when you are given parallel lines. So the first Z that I see is right here. Now there's multiple options here. We could also talk about the one that's formed here. So I know that these two angles should be congruent and these two should be congruent. So I want to see if one of those is our choice in this problem. Angle CFG, C to F to G, should be congruent to angle FCB. Whoa, it looks like we found it in choice A. CFG, right here, is congruent to FCB. When I highlight those, I get a Z again. So it is choice 1 here, but I just want to read through another one so you can see why it's not any of the other choices. The next one says that we have angle ABF. ABF should be congruent to angle BFC. Now it sort of looks like a Z, but it does not use the fact that we have parallel lines. AB is not parallel to FC, or we're not trying to get that. We're trying to get ABCD parallel to EFG. So again, choice 2 is not going to work. And if you read through the other ones, just highlighting the letters as you go, you'll find out that choice 1 is the only one that gives us a Z, and the only one that gives us any of these pairs of angles off to the right. Number 18 says, in the diagram below, CD is the image of AB after a dilation of a scale factor K with the center at E. So here we're centered at E and we're dilating segment DC, or CD, such that it maps onto AB. When we're given a center of dilation other than the origin, it's very helpful to take your pen or pencil and your ruler or your straight edge and connect them to make straight lines. So E connected through D, connected through B, and E connected through C, connected through A. So now we have this figure that looks like something that we're used to seeing, where we have E, D, C, B, A. It says which ratio is equal to the scale factor K of the dilation. Now it's hard to figure out what the scale factor is. It's certainly possible, we can do it, but it's not totally necessary here. If we can find a ratio that would relate pieces of information to one another, then we can figure out which scale factor was used here. So let's start by thinking, say, top over bottom. It's the top of the triangle over the bottom of the triangle. So something like ED over DB. Well, that's not a choice, so let me try the other side. The top of the triangle, EC, over the bottom of the triangle, CA. EC over CA. That's not a choice either. So now let's consider, top over whole. There's a lot of options to consider here. I'm just thinking about different parts of the triangle. So the top, again, ED, over the whole side, EB. ED over EB. Not a choice. Okay, so let's try the right side of the triangle. EC, top over whole EA. EC over EA. That's choice 1. Again, if we think about ratios and dilating from a scale factor other than the origin, connecting helps you figure out the ratio of the scale factor. First, we took E and brought it to C, so down 2 over 2. But then we did that several more times in order to get to A. So here it looks like we did down 2 over 2, down 2 over 2, and then we went down 1 over 1. So this is a scale factor of 2.5, which is the same as the relationship of EC, the original, to EA, the new. EC to EA. So our choices, our answers for this page are number 17 is 1, and number 18 is also 1. Number 19 says that a gallon of paint will cover approximately 450 square feet. An artist wants to paint all of the outside surfaces of a cube. Outside surfaces means surface area of a cube. A cube is a special rectangular prism where we have congruent sides that measure 12 feet on each edge. So here, think of like a Rubik's Cube. Start with a square, build it backwards to make another square. And each of these edges is 12. Surface area means the area of all sides. So because it's a cube, all sides have the same area. So if I find the area of one side, length times width, or in other words 12 times 12, I know that the area of one side is 44. So to find the surface area, I take 144 and multiply it by all 6 sides to give me a total surface area of 864. But now I want to paint, or this person wants to paint, an artist wants to paint, and each gallon of paint covers 450 square feet. So in order to find the number of gallons, I have to do some division here. I have 864 square feet, and I know that each paint can will cover 450 square feet. So here my units cancel, and 864 divided by 450 leaves me with an answer of 1.92 when typed into the calculator. So here I can eliminate choice 3 and 4 because those are too high. But now I'm stuck deciding between, is 1 gallon of paint enough, or do I need to buy 2? And because we have a partial gallon, 0.92 of a gallon, I have to round up to 2. Because 1 gallon is not nearly enough to cover it all, and 2 gallons would allow me to cover the entire surface. So 2 is my choice. Number 20 says, in circle O, shown below, diameter AC is perpendicular to CD. Because AC is perpendicular to CD, we now have a right angle. So here I have a right angle. And chords AB, BC, AE, and CE are drawn. Which statement is not always true? So if we look through these statements, they're written all about angles with 3 letters, so we have to be very careful about where we're looking at on our picture. The first one says angle ACB. Angle ACB is congruent to angle BCD. Now, they might look congruent, but angle ACB, the purple angle, is supposed to be equal to half of arc AB, because that's the arc that it intersects. And angle BCD, the green angle, is supposed to be half of the arc BC, because that's the arc that it intersects. So I don't believe that this is a true statement, but let's continue working through the other ones just to be sure. I'm just going to erase my marking so I can mark it up again. Choice 2 says that angle ABC, this angle here, is supposed to be congruent to angle ACD. Now we know that ACD was a right angle. And we also actually know that angle ABC is a right angle as well, because ABC is an inscribed angle on a semicircle, which means that it's a 90-degree angle. So this is a true statement. Number 3, I'm going to again erase my markings. Number 3 says angle BAC is equal or congruent to angle DCB. Now if you look at both of these angles, the purple angle intersects arc BC, and the green angle also intersects arc BC. Both of these are inscribed angles, meaning on the edge of the circle. We can write inscribed angles. And so because they intersect the same arc, they must also be congruent. Number 4 says that angle CBA, my 90-degree angle here, is congruent to angle AEC. Ooh, angle AEC is also inscribed. It's on the edge of the circle, and it's intersecting a semicircle. So here angle AEC is also 90 degrees. So this is a true statement, leaving us with choice 1 as our final answer. Number 21 says if in the diagram below triangle ABC is similar to triangle DEC. Whenever we see a similarity statement like this, we should mark up our picture with circles, squares, and clouds. A maps on to D. So I'm going to put a circle around both. B maps on to E. So put a square around both. And C, of course, maps onto itself. So now here I know that AC is equal to 12. So AC is 12. DC is 7. DE is 5. And the perimeter of triangle ABC is equal to 30. Now because we know that these triangles are similar, we know that the ratio of corresponding sides is equal to the ratio of perimeters. So here, if I set up a ratio of corresponding sides, then I can also set up a ratio to help me find the perimeters, because our goal is to find the perimeter of triangle DEC, and we'll call that X. So ratio of corresponding sides, now I have a couple of options. I have AC matches with DC, that's circle to cloud, circle to cloud. And then I see a 5 over here, but the 5 is going from circle to square. DE is 5. And I have no number, no value for AB, so I can't actually use the 5 here. So I'm going to set up 12 over 7. That's my big triangle to my small triangle. So when I think about my ratio of perimeters, I now have my big triangle of 30 over my small triangle of X. And in order to solve this proportion, we cross multiply. 12x equals 210. Divide by 12. So then x equals 17.5. So the perimeter of triangle DEC is 17.5. Choice 4. So again, the answers for this page are number 19 is choice 2, number 20 is choice 1, and number 21 is choice 4.